Hey again, the third question that we're going to cover deals actually with Dalton's law. So the question is, you have a balloon, okay, and the balloon is at standard temperature and pressure. So right away I'm going to write my given, and I'm going to write standard temperature and pressure. 25 degrees Celsius, as we know, is temperature, and then pressure 1 atm, okay. And they're saying that inside this balloon I have 2.2 moles of oxygen. So I'm going to say the number of moles of oxygen is equal to 0.2 moles. Okay? And 0.6 moles of nitrogen. So the number of moles of nitrogen is 0.6 moles. Okay? So those are my givens. And then they're asking me, so I want the partial pressure of oxygen in the balloon. So I want P of oxygen, okay? Now, the first question I guess you might be asking, the first thing you should do is always just write down what it is that you want, what you were given, and then the first question you should ask yourself is, which formula am I going to use? Now, we talked about the ideal gas law. The ideal gas law is not appropriate for this situation because I am asking for a partial pressure. I'm not asking for the total pressure of anything. As a matter of fact, I was given the total pressure, but we'll worry about that later. So the moment you see they want partial pressure, you're going to be doing something that has to do with Dalton's laws. Now we need to filter through all the stuff we learned about Dalton and figure out what equation we're going to use. So I'm going to start by just writing, what are the, we learned about Dalton that, for example, the total pressure, PT sub T in a system, is just equal to the sum of all the partial pressures. So in this balloon, we're assuming that there are only two gases, okay? We're assuming that the total pressure is made up of, the partial pressure of the oxygen gas plus the partial pressure of the neon gas, okay? So now, the next question I'm going to ask is, can I use this formula to solve? I want the partial pressure of oxygen, which is here, okay? In order to use this equation, I would need the total pressure and I would need the partial pressure of nitrogen. So I'm going to look over here at my given. Now, when I tell you standard temperature and pressure, that is the total pressure, okay? But do I see the partial pressure of nitrogen anywhere here? No, I don't. So now I'm going to have to use the other equation that we talked about. And again, if you don't want to memorize it as an equation, I couldn't care less. All I want you to remember is the logic. If I multiply the total pressure by the fraction of oxygen in the system, they call it the molar fraction, then that will give me the partial pressure of oxygen. So again, if I multiply the total pressure of the system by the molar fraction of oxygen, then I will get the partial pressure of oxygen. So that formula, I'm not sure if I should change colors, but I will. That formula would say that if I want the partial pressure of oxygen, what I would have to do is I would have to multiply the total pressure in the system by the fraction, the molar fraction, the fraction that oxygen is contributing to that system, okay? And this X, we learned what it is, right? Just basically, if I want to calculate this molar fraction, all I do, the molar fraction of oxygen, would just be equal to the number of moles of oxygen divided by the total number of moles, okay? And in this case, that means that the molar fraction of oxygen is equal to the number of moles of oxygen divided by the number of moles of oxygen plus the number of moles of nitrogen. Okay. So step 1, we wrote down what we wanted and what we were given. Step 2, we found the appropriate equation. Now I went ahead on step 3. I made sure that I have all of the information, or that I can convert and get all of the information in order to plug into this equation that I'm going to use. Okay, so now we're on step 4. And all I have to do now is say, okay, my partial pressure of oxygen is equal to the total pressure. We're going to stay with ATMs because that's what the question is using, multiplied by this mole fraction, okay, which is over here. I'm just going to put it all in the same fraction bar. It is the number of moles of oxygen, 0.2 moles of oxygen, divided by the total number of moles, okay? What is the total number of moles? It's NO2 plus the number of moles of oxygen plus the number of moles of nitrogen. So it's 0.2 plus 0.6 equals 0.8 moles. So 0.8 moles total, okay? And when you work that out, that's it, that's your answer, okay? And notice that moles and moles cancel, so your answer will be in the units of ATM. Okay. Now, if anyone actually wants to know what the answer is, I don't have a brain at the moment, so I don't feel like doing this in my head. Yeah, whatever. It's a 1/4. I don't know. Okay, so yeah, it's A. Okay. So anyway. This is just a quarter, which is 0.25 ATM when you wind up getting your answer. I had a blonde moment. I don't know if I can stop the video.